After the introduction of refrigerants and its properties, various refrigeration system, let us start with the refrigerants. In the refrigerant section, we'll be having the understanding of desirable properties of our refrigerant, its nomenclature, the classification, the various environmental aspects of refrigerants, as well as its impact on different type of conditions. So initially, the refrigerant as a definition, you can say it can be considered as a fluid which is used in refrigeration cycle to cool a space. Generally, the refrigerant absorbs the heat and release it in another space by using a thermodynamic phenomena of phase changes that we have discussed in the previous lecture. So in that refrigerant, a working fluid in the compression refrigeration system must satisfy the different numbers which is having component wise and a suitable environmental and personal safety, including all type of chemical, physical and thermodynamic properties must be satisfied before considering a refrigerant into the refrigeration cycle. So here the thermodynamic properties, where boiling point is considered to be low for a better refrigerant. Similarly, freezing point, it should be as minimum as possible. It should not freeze in any of the condition. The evaporator and condensation temperature should be dependent on critical temperature and pressure, and the latent heat of a refrigerant should be high. These are some of the few thermodynamic properties. Similarly, safe conditions of refrigerant including toxicity, flammability, corrosive properties, chemical stability and effect on stored product. So nothing is desired basically. Chemical stability is a property where it should not form any bonding with the material where it is being stored or being circulated. Similarly, it should not have an effect on the stored product, like in refrigeration system. The refrigerant should not have any adverse effect on fruit or vegetables or whatever the perishable items. Like in physical properties, like specific volume, specific heat, thermal conductivity, viscosity and dielectric strength. These are the few physical properties which is having their specific values. Like dielectric strength is related with the electric motor which is used in combination with the refrigeration system. Other properties like high COP, minimum horsepower requirement, it should be viscous enough so that it should not leak to the atmosphere or outside the refrigeration system. Odorless, it should not be miscible with the oil. So oil, whenever comes in contact with the refrigerant, it should not be miscible. And availability and cost. Availability is most important factor, as for a large industrial plants there shall always be possibility of requirement of additional refrigerant. It should be available easily. In the classification of refrigerant, it is based on the standard international nomenclature, where R will be considered as the short form of the refrigerants, which is followed by 2 or 3 digit numbers, or sometimes specific cases for 1 or 2 letters. The designation RXYZ is determined by the chemical composition of the molecule. Like R is for refrigerant, X having different numbers, Y will be having different numbers, and as Z. So X start from 0. So whenever we put X is equal to 0, it will be a methane series. But 0 is ignored, therefore we can define R0, suppose 11. So it the refrigerant name would be R11. or R12 because 0 is ignored. So these are the name of the refrigerants which was used earlier as R11, R12, R22 in the methane series. Similarly, when X is equal to 1, it is the member of ethane series like R114, R124 and R134A. R134A is the refrigerant which is presently used in household refrigeration and air conditioning facilities. Similarly, if we replace X is equal to 2, then it becomes the propane series like R290 become the propane refrigerant. For this group, the Y describes the number of hydrogen atom plus 1 and Z describes the number of fluorine atom. So what is X? X is the number of carbon atom, Y is the number of hydrogen atom and Z is the number of fluorine atom. C, H and F. Like these are previous slide is related with the direct refrigerants which is having single compound. Now when we use geotropic and azeotropic mixtures, means two additional refrigerant will be mixed. When two refrigerants are mixed, it becomes geotropic. When more than two refrigerants are mixed, it becomes azeotropic mixtures. So when previously X was started from 0, 1, 2. Now X is equal to 4 or 5 is related with the geotropic and azeotropic mixtures like R407 and 407A and C are the example of such refrigerants. Similarly, X is equal to 5 refers to the azeotropic mixtures. R507 and 502 are the example mixtures. In that geotropic and azeotropic mixture, Y and Z would be considered as ordinal numbers. Next category is high organic compound. So when X is equal to 6, it becomes butane, considered to be organic. In this category, one refrigerant which is popularly known as isobutane, R600A. So this subgroup has assigned different number series where Y and Z describe the subgroup and order within the subgroup. The next series is inorganic and unsaturated organic compounds with X is equal to 7 and X is equal to 11 and 12. So X is equal to 7 refers to the inorganic compound and such as ammonia R717, water R718 and carbon dioxide R744. These are the future refrigerants or the refrigerant where researchers are working on it so that they can be used as a primary concern because it has the minimum effect on the environment. So in that particular group where X is equal to 7, Y and Z are the molar mass of these compounds. Next is unsaturated organic compounds. It is 11 and 12 which is related with the ethylene and propylene only. So these are some of the ethane and propane series mixtures or refrigerants which is used for some specific industrial application. And the letters at the end, it means if any lowercase letter describe the structure of the molecule will be considered as the subgroup of this particular compound. Like butane is R600 and R600A is the isobutane. So we can define in this manner. General classification: primary and secondary refrigerants. Primary refrigerant which does not take directly in the refrigeration process, or which takes the directly part in the refrigerant process, and secondary refrigerants which are firstly cooled by the primary refrigerant and then used for the cooling process. The major category is CFC, chlorofluorocarbon, where in the atoms the molecules are chlorine, fluorine and carbon. Then hydrochlorofluorocarbon, HCFC, then HFC, hydrofluorocarbon, and hydrocarbon. These are the general category of the refrigeration compounds. Now, apart from the classification of the refrigerants, there are several chlorine-based refrigerants. All refrigerants are related with the environmental sustainability. Like, there is a question in some minds, like how an air conditioner refrigerant affect the environment. So as we know that the ozone layer is located around 35 miles above the ground, and this layer of ozone protects the earth's internal atmosphere from the sun's ultraviolet rays, and these rays are harmful to the planet. Now, this air conditioner having refrigerant which may damage the ozone layer. So after the analysis, it was found that the refrigerants which comes under the category of CFC and HCFC are damaging the ozone layer slowly in the family of chlorine, fluorine and carbon. In this family, the chlorine main compound which causes the depletion of the ozone layer. Therefore, the Montreal Protocol comes into the picture, which was signed by 180 nations in 1987 to phase out the production of CFCs, chlorofluorocarbons, by 1995 and hydrofluorocarbon by 2030, which is now reduced to 2020 this year. So if we phase out the existing refrigerants, what would happen? The requirement of adoption of new refrigerant will become the concern. So as azeotropic and geotropic mixtures can be used as a new refrigerants. Now, therefore, category now extended to the refrigerant blends also. So CFC, CFC and refrigerant blends. The picture gives the idea how refrigerants are stored in the cylinder. This is for R134A. So once the Montreal Protocol was over, then slowly in 1997 Kyoto Protocol was signed, which is related with the global warming. Global warming is related with the greenhouse effect, which is man-made greenhouse gas emissions, mainly carbon dioxide, nitrogen dioxide, carbon monoxide, and all these refrigerants. So many refrigerants are known as negative impact refrigerant on the atmosphere because they contribute the global warming and also deplete the ozone layer. So there are two concerns. One is global warming potential and second ozone depletion potential. How does it affect? If the global warming potential of a refrigerant is a measure of the amount of heat or gas which will trap in the atmosphere over time as compared to the carbon dioxide, which has a baseline global warming potential of 1. Thus, a gas with GWP higher than 1 traps more heat than carbon dioxide. And similar description for ozone depletion potential is also found, which is for a chemical is a measure of how much it causes degradation of the ozone layer as compared to the CFC level, so which is a baseline ODP is 1. So thus a chemical with an ODP over 1.0 will degrade the ozone layer more than 11, the previous one, or the baseline refrigerant. So if we combine the effect of different type of refrigerants on ODP and GWP, it can be concluded that the CFC, HCFC and HFC, first three refrigerant, which is synthetic refrigerants, comes under the category of synthetic refrigerants having very high ozone depletion and global warming potential, while HC and CO2 based refrigerants having zero and negligible ozone depletion potential and global warming potential respectively. These refrigerants are the natural refrigerant. Now the discussion on refrigerants is almost over.